Warm greetings and wishes to the students and friends. Today I am going to find the video lecture on the crushing strength of the column, especially the short column. In the previous video we have seen about the critical load or buckling load of a long column. So today we are going to see about the crushing strength of the short column. The short column is defined as the ratio of effective length of the column divided by least radius of gyration is less than 12. That is called as the short column. So lambda is equal to L effective divided by R minimum or K minimum. So here a short column which is of effective length 2.5 meters and of size 0.3 meter into 0.4 meter, subject to a load of 100 kilonewton, and the Young's modulus of the material is 0.15 into 10 power 5 MPa, and also the column is of concrete column, the RCC material. Here we have to find the either the short column or long column, so as per the given things. So if it is a short column, we have to find the crushing strength is equal to load divided by the area of the given column. So here column is of 0.3 meter into 0.4 meter. So if you are finding the lambda, that is the slenderness ratio, that is equal to L effective divided by R minimum, where L effective is the effective length of the column divided by minimum radius of gyration. If you are working out, it will be working out less than 12, so it is a short column. So if you are able to find the area, A is equal to 0.3 into 0.4, you will get in meter square. And what about the crushing strength of the column, FCR? F suffix ER or P, small p suffix ER, that is the critical strength or the crushing strength of the short column, that is equal to the load divided by the area of the given column. So here the load is given as 100 kilonewton divided by area is 0.3 into 0.4 meter. If you are working out, you will get the crushing strength of 833.4 kilonewton per square meter. So the crushing strength is 833.4 kilonewton per square meter. If you are working out for the newton per square millimeter, so therefore FCR is equal to 833.4 into 1000 divided by 10 power 6. If you are working out, you will get as 0.8334 newton per square millimeter. That is equal to 0.8334 megapascal or newton per square millimeter. So this is how we have to find the crushing strength of a given short column. So it is mainly failed due to the crushing failure, not due to the buckling failure in the case of the long column using the Euler's theory for long column. So we are saying about the short column only. So the crushing strength is 0.8334 newton per square millimeter or megapascal. If you are working it for kilonewton per square meter, it is 833.34 kilonewton per square meter. So this is how we have to find the crushing strength of the short column. So first of all, you have to find the lambda value, whether it is short column, long column. So after that only you have to decide whether it is going to fail by the crushing failure or by means of the buckling failure or the buckling load in the case of a long column. So since it is a short column, it is very easy to find the crushing strength or the failure at the point for the short column. Anyway, so the problem worked out right is shown here. This is the given problem. So we are finding out the lambda value, then find the crushing strength FCR. You can see that the value will be of 0.8334 into 1 newton per square millimeter, or you can get as 833.4 kilonewton per square meter. So this is how you have to find the crushing strength or critical load for a short column. Thank you very much for patient listening. We can see some problem in the case of a long column or the Euler's theory for the long column. Thank you very much. God bless. வாழ்க வையகம், வாழ்க வளமுடன்.